to make the introduction of Mr. Sauvir Sarkar, who is our third speaker in the panel, and invite him to give his presentation. Mr. Sarkar is the head of new construction and engineering division at ASRI, the shipbuilding yard and repair facility here in Bahrain. Mr. Sarkar is a graduate naval architect with a postgraduate in business management and a 35-year career spanning several industries, including 12 years at the Lloyd's Register and the rest in shipbuilding and ship repair yards. Some interesting projects that Mr. Sarkar has worked on are LNG propelled vessels with integrally safe concepts, offshore support vessels with electrically propelled cycloid propulsion systems, diesel electric vehicles, and jack-up rigs, all with a view during these projects to reduce the environmental impact of the systems and provide fuel savings. He is also responsible for construction activities and infrastructure activities in the ASRI yard, which is where I first had the pleasure of working with Mrs. Sauvir when we worked together to develop with the SEA as part of a capacity building program to train local energy auditors. We offered a joint project with us and ASRI to investigate energy conservation opportunities within the yard. I'm sure Mr. Sauvir will discuss this in more detail, so I'll hand the floor over to you, Mr. Sarkar.
Thank you very much indeed, Rami. Excellency, ladies and gentlemen. First of all, I must thank you for the opportunity provided in the second annual International Sustainable Energy event being hosted by SEA and the Bahrain Institute of Engineers. I'll just share my screen, the presentation first, and then we'll take it from there. Yeah, so Rami has given the introduction, and the topic he has given is energy auditing pathways to operational cost reduction. And the case study obviously is ASRI. Just to tell you that we have had a very close relationship with SEA, even years back when it was SEU. And based on their involvement inside ASRI, I think it was from 2017, as Rami said, we had an energy audit carried out by a national expert along with local experts in looking at ASRI in terms of savings, potential savings in terms of energy. ASRI being one of the largest, large energy consumers in Bahrain. Just to give you an essence of what ASRI is, where it is, we call ourselves a multi-yard. Of course, it's in the Kingdom of Bahrain. We started off our operations, our construction in 1973, and we've been in business from 1977. So you can well imagine, we're talking of equipment in a shipyard, quite old, and it's very important, therefore, that energy efficiency is invested on and created from time to time. Our business mainly is in terms of ship and rig repair, conversions inside ship and rig repair, many of them towards improving energy efficiency of our clients. We have now been with the National Oil and Gas Authority in Bahrain, with a company led by Mr. Mazen Matar, who is our managing director. And under the NOGA leadership, we are going through a 3-year modernization plan, which will cover further investments on modernizing the yard and including energy, reducing energy efficiency, increasing energy efficiency, I beg your pardon. We've also diversified recently into oil and gas, and it will also cover engineering, construction, and repairs in the oil and gas sector. Just to come to why ASRI's energy is high, the consumption is high, I'll just tell you what ASRI's business is. We are into ship repair and rig repair, conversions in ships and rigs, repairs and conversions of the navies. We have many of the navies, the world navies, like the US Navy, the Australian Navy, the Royal Navy, and of course the Bahrain Navy in this region, in our strait, present in Bahrain. And of course, we are now a Noga company, and we want to be of use to our sister companies like Babco, Tatvir, etc. And we're getting into oil and gas-based construction and repairs. We do approximately 250 projects a year, and it's a large infrastructure of over 1.4 square million square meters. That's over 400 acres, with a workforce of about 5,000 people. Uh, since we deal with ship repair, shipbuilding, we have docks, quaysides, cranes, workshop, all very energy intensive. And since we have so many people, we have our own camps where we house 3,500 personnel. So you can well imagine what sort of HVAC loads we are talking of. This is all because of this. We consume about 70 gigawatt hour of power every year, and it's a significant energy expense for us. Just to give you an essence of how the power is distributed, we get a 66 kVA kV line from EVA, and then we step down to 11 kV. And we have two substations, one which started in the inception of R3, and second is during the modernization plan, which is substation A. And then you can see all scattered along this 1.4 million square meters. We've got 20 substations all over. So this sort of gives you a sense of how R3's power distribution is, which caters to that 70 gigawatt hour of energy consumption every year. And why is this power demand? Because we've got ships coming next to our berths, we've got graving docks, we've got floating docks, we've got slipways, uh, we have got cranes, mobile cranes, all sorts of cranes, and all these are built pretty old, and but they're very good in terms of their efficiency, in terms of their working efficiency. It's just that we have to keep maintaining them to keep them to the best standards. Other machinery, other equipments, very is of course welding. Welding is a major part of shipbuilding, ship repair, and you can see that we've got 843 welding machines of various sorts. Very, very important for us is blasting, painting. So compressor stations is a big load out here. Because we have blasting paintings, you've got a number of dehumidifiers, ventilators, and of course we have to deal with portable generator sets if in any case there is loss of air or loss of power at any one location of the yard. We have a number of workshops which takes care of steel fabrication, pipe fabrication, mechanical. So as a result of which we've got a number of machinery, lathes, boring machines, drilling machines, CNC cutting machines, bending machines. All these machines are in the yard, which contribute to a lot of power consumption. Now, this is what SCA helped us with, and it was a very valuable input what we got when we had this energy audit in 2019. This gives you in 2018, of course, since 2019 the audit was held, they did a full analysis of the electricity consumption in 2018. And what came out there was air compressors contributed almost 21% of our energy consumption. AC cooling was 17%, welding was 16%. We house a lot of people in our canteens, in so that was about 7%. Dehumidifiers, as I said, used for blasting, for painting, for keeping the condition in these tanks on ships, that contributed about 5%. So these were the figures which we came around, and we are talking and various areas of improvement like power factor improvement, improving welding by getting new technology into welding transformers, trying to do changing diesel driven cranes to electrical driven cranes, like having frequency control for water pumps, having LED lighting, maintaining dehumidifiers, using dehumidifiers in a way where we don't use it more than what is required. So there's a series of improvement measures which was also identified during the energy audit by SCA. And we're talking of approximate saving potentials at that point of 1.5 million a year. And this is an extremely beneficial saving, in terms of our operational costs. So what ASTRI did was we took up several initiatives, and I have basically categorized them into seven initiatives, which was where we made investments. And fortunately, those investments, we can measure what we have got, what the returns are on those investments after they've been installed. So the first one was welding cost reduction. What we did was basically we were more into manual metal arc welding compared to the modern semi-automatic welding process like the flux core arc welding, for which we required more of inverter-based welding transformers. So we purchased about 100 inverter-based transformers from Lincoln, and with it we got a saving of almost 16% on various aspects: consumable cost reduction, manpower reduction because the process was much faster, improved delivery of work because it took much lesser welding hours, reduction in the total number of welders, improved quality of welding. So this was a big thing where we went away from 10% FCAW welding, that's flux core arc welding, to 40% flux core arc welding. And this is, you can see these machines now. Now these are now installed on ships. And then you see the welder out here, he's got his backpack along with him, a very light machine where he can control the voltage current from the location at which he is welding. Now, of course, we have come to 40%, but that's not what we are looking at. We're looking at improving FCAW semi-automatic welding to take it to the next level of 70%. And then we should get more savings in times to come. The second initiative was, installation of capacitor banks. We have to deal with a number of inductive loads. We've got welding transformers, dehumidifiers, machine shop motors. And because of that, we are having, and some of them are old, because of which our power factor was below zero point 0.9. And as you know that we have a penalty because of bad load or inductive loads in Bahrain. And that sort of means that brought us to installing capacitor banks. So we have installed capacitor banks on the 11 kV side. And with it, we can see that at least on two feeders, which cater to the main motor-based loads, we can see an improvement in power factor from about 0.82 to 0.88 to 0.96. I've shown you the figures can be seen out there. And this is something, this is a big saving for us, which is, we have not monitored all the months because the saving we've been monitoring from November. And approximately we are talking of somewhere around 50,000 US dollars a month, which is 600,000 US dollars a year, compared to spending about $400,000, I think, on these capacitor banks. This is a huge saving for us. These are the capacitor banks which have been installed in our substations. I showed you substation a while back and how it's been connected on to our grid. The third initiative what we took was improving LED lighting in the docks and in the shipyards. The idea was also not only from an energy point of view, but also from a point of having some lighter equipments which can be handled easily in our dry docks, so that we could do work in the night. So you can see out here that obviously it is reduced power consumption, and the saving is of the order of about 220 kilowatts, which is around US dollar 75,000 per year. On the right hand side, you can see these lights which have been fitted on the graving dock on the dock side, which provides the lighting for mainly for our blasting department, for our the dock testing departments, auxiliary departments. And not only does it improve productivity, but it's also led to reduction in energy consumption. We replaced a number of our late machines. They were all old machines consuming more amount of power. And what we can see now is that has also resulted in almost a 25% saving in terms of machining hours, which is approximately about US dollar 68,000 per year. This is something which is ongoing now, and it's already kicked off. We have identified about 97,450 square meters for PV panels, so that means out of our 70 gigawatt hour what we consume, we can have about 16 gigawatt hour coming out from solar PV panels. This is going to be about 8 to 10 megawatt in power in terms of capacity. And this will be fitted on our workshop roofs, which primarily contributes the major part of the 97,450 square meters. In addition to that, it will also be on some ground mounted locations, which we have identified, because we don't want to give away areas from a work perspective. We have not invested so far on or we have not investigated too much on the wind part of it, the wind turbines, although the Wind Atlas shows RC to be in a very favorable position in terms of wind turbines also, and that's something we'll do it in the future. Now, we showed you that the audit results was that air compressors was something which had a large amount of load in terms of energy consumption, air conditioning, welding, canteen. So what we started with, for example, for the air compressor, it leads to it's primarily because of leakages in air at various locations. So what we used to do was we used to hire generators at those times where you have a lower pressure of air, because the pressure which is there is unable to cater to the requirements of blasting. So now what we have done is we have a very good preventive maintenance by which we ensure that all these lines are tight, and which means allowed us not to hire generators for blasting. Whatever air conditioning there is, as I told you, we have 3,500 people staying in our camps in addition to our office buildings. So whatever air conditioning we are replacing these days is with the latest technology, and all the latest technology have got a much lower power consumption. Welding transformers, I just described to you that it was a great saving for us, and which has also helped us in getting higher power factors. Canteen is a very good example. This is, of course, not only because of the energy saving, but also because of the pandemic that we thought of it that why not do this? And we stopped having people getting into the canteens and instead started with a parcel service, which not only allows us to control the pandemic, but also gives us energy savings. And then dehumidifiers, we talked about it, there was a tendency to use these dehumidifiers unnecessarily, where you can use, when you have already completed your painting in a conditioned manner, you could use ventilation fans as well for means of providing ventilations. So all this was an initiative which we took in improving energy efficiency. Now, reducing carbon footprint for our clients is also one of our objectives. Like we've been installing scrubbers, we heard of waste heat recovery, and we do waste heat recovery in ships for our clients. We do fuel savings devices on ships, in front of propellers, wake inducing device by which we have been able to reduce fuel consumption by about 2%. As you know, worldwide, there is a tendency of vessels, of ships, to be moving away from diesel engine propulsion to LNG propulsion. Now, what that does is basically it reduces CO2 emissions by 20%, and of course, SOx, NOx, and particle matters by over 90%. So this is something which we are catering to clients, to tell clients that we are very much worried about your carbon footprints. We are now getting into, on low powered boats, things like landing crafts, where we can have solar powered means vessels. Now, you obviously cannot do it for high-powered boats, but for very slow-powered boats, which we have a number of cases in Bahrain, we're going to look at this option also of using solar power. ASRI is also looking at building and converting vessels with battery and hybrid power. This is mostly on the offshore sector in fishing trawlers, offshore support vessels, and all this is basically also towards energy savings as a part of IMO's requirements for compliance in 2030. These are typical examples. You can see on the left, we heard about waste heat recovery, and this is a waste heat recovery boiler, what we did on a ship. Scrubbers, we've done a number of scrubbers, fuel saving devices, which is basically fitted in front to make use of the wake of the propeller in reducing the energy. These are examples for the future on the right, which is LNG fueled as well as solar powered vessels, which we are now looking at. Just to get back to summarize everything, ASRI, as you have seen, has got a very large operation in Bahrain. It's a single location with significant energy consumption. We are, as I told you, we are extremely energy intensive. SEA has helped us in streamlining and improving energy efficiency. And this has really helped us in also in getting production efficiencies. I was just calculating something on the major initiatives, three of the major initiatives, which is basically capacitor banks, welding transformers, and LED lighting. And the saving per year, the figures are obviously, we've just got it for the next 3 months, but if we continue the same figures for the whole year, we're talking of somewhere around $850,000 of saving per year with an investment of about $1.5 million. And some of these are the capacitor bank is, the saving is at this rate in less than a year. And if you talk of welding transformers, if you talk about LED lighting, it's somewhere between 3 to 4 years, which is extremely good. As I told you, we are now owned by NOGA, and they're continuously looking at modernizing Austria in terms of energy efficiency, in line with the Bahrain and international commitments of NEAP, NRP. Like, not only that it is ASRI's requirement, that it's also our obligation in introducing energy savings for ship owners and flag states. Thank you very much indeed.
Thank you so much, Mr. Sarkar. Thank you to all of the panelists. I think we've had some really interesting presentations. And again, as I said at the offset, we really looked at the regulations around energy efficiency, particularly in the area of buildings. Then we looked at some new technologies, emerging technologies that could be used to improve energy efficiency in several areas around wasted heat. And the case study, which is a shining example, and Mr. Sarkar did an excellent job of showing us really the potential benefits of energy efficiency across his particular facility. So I'm going now to